All right. All right, guys, so your learning target today is to explain how and why bonds form between atoms to make molecules. So we're going to obviously be talking about molecules. And then you guys can identify atoms and elements in a formula. So if I give you guys a formula, you guys would be able to tell me the different elements and then how many atoms of those elements are in there. And then finally, you guys can define what a molecule is and explain why bonds form using the octet rule, valence, electrons, and energy levels. Okay, so you guys have already added those. Let's go ahead and flip to page 21 in our notes. You guys' title there will be molecules. I can go ahead and push this back then. So why did it not follow me over here? Oh, now it goes. Story of my life. Okay. All right. So molecules. Who can tell me what a molecule is? Buck? Perfect. Yeah. We're going to have multiple atoms or elements. So molecule is two or more atoms or elements that come together to make a new substance. So something like sodium, for instance, we know sodium, if we throw it in water, is reactive. It'll explode in that water. Okay? But when we put it into a compound, it's going to lose those properties. It's going to have different properties. So for instance, salt, table salt, is sodium chloride. We obviously have sodium in there, but if we throw salt in water, is it going to explode? No, because that would ruin your guys' lives, especially when you go to the ocean. Okay? So, again, when we form new things, we've changed the identity. They become something completely different, which is very helpful for us. Okay? Do you guys all get that? No? Yeah, no? Do you need to go back up? Okay? You guys set? All right. They are going to interact with each other using their valence electrons. So anytime we form a compound, the reason that we're forming that compound is because we have something going on in our outer energy level with our valence electrons that's forming this compound. Okay, it's creating some kind of bond, which we'll talk about more, and those bonds are because of valence electrons. All right, so there's two types of molecules that we're going to be studying. We're going to go into great detail on these two different types of molecules tomorrow. In class, we'll talk about what a covalent molecule is and what an ionic molecule is. Okay, we'll be able to compare and contrast them. But for today, we just need to know that there's two types. Okay. On Wednesday, we'll have a lab. You guys will have a bunch of ionic and covalent substances, and you guys will be doing some different tests on them. To kind of look at their different properties. So one of them will be like, can it conduct electricity? I have this little light bulb apparatus where you guys will stick the solutions under the light bulb. If it has the ability to conduct electricity like ionic compounds do, then that light bulb will light up. Okay? So again, we'll talk in great detail about those tomorrow. There's more than those two types. Those are the only kinds that we're addressing. If we look at like steel, for instance, steel is a bunch of different metals that come together to form a new compound. So there's different types other than ionic and covalent, but those are the two base ones that we use. All right, so why do we form bonds to begin with? Someone raise their hand and tell me. Why do you guys think we got to form bonds?
Become reactive.
Buck, disgusting.
Become more stable.
So they're definitely going to be more stable. That's going to be our second reason. Lower energy or more stable. But why are they more stable? Anyone know? Someone other than Buck this time. Garrett, what do you think?
They can add electrons to the valence when you put it up.
Right, exactly. What's that rule called?
Octet.
Their octet rule. So the main reason is that bonds are going to form between multiple elements to complete their octets. So for instance, carbon has 4 valence electrons. Instead of losing 4 or gaining 4 to form an ion, what it's going to do is it's going to find some different elements that you want to share with them. So they'll kind of share, hey, here's my 4, if you share some of yours, and they're going to form a bond. That's going to be what we call a covalent bond. On the other hand, we can still form ions, and those ions can attract to each other like magnets, and that's going to be basically what an ionic bond is. But for now, all you guys really need to know is the whole reason that we have elements that come together to make something new is so they can get their octets full. Okay? With that being said, if they have a full octet, then you guys have provided a more stable molecule with a lower energy. Okay? It's less likely to be reacting with anything else. And that's a good thing. Please tell me what is not cool about this mug. I'm going to try science. This one holds more. I do like that one, though. Okay. You guys got that? Don't tell me my business. Got it? All right. Last little part is you guys are going to draw this. This is the last part on this page. You guys are going to draw a 3 and then H2O, and we're going to talk about what each of those mean, like you guys don't know because it's not listed on the board already for you.
Is that like we don't have anything else on this page tomorrow?
Nope. We'll be moving on to a whole new page tomorrow. Okay? So, the green ones, without even having to see what they are, what are the green ones, guys? Those are the elements. So what elements are in this molecule? We have hydrogen and we have oxygen. Okay? Again, it's really important that you guys make sure to write the symbols correctly. For instance, if you guys are looking at like carbon dioxide or carbon monoxide, and you guys write a big C and a little O, you guys have just wrote cobalt instead of carbon monoxide. Okay? So make sure you guys are writing your symbols correctly. Always check your periodic table. Okay? In orange, we've got this little subscripted 2. What does the subscript tell you? Right, it's going to be the number of each atom. So how many hydrogens do we have? 2. How many oxygens? 1, right? We do not need to write a subscript of 1. We have written the atomic symbol for oxygen, so we know that there's 1 atom there. Okay? Do not write a subscript of 1. Okay? So again, the subscript, sub means below, script is writing, so you're writing below, is the number of atoms of each element. So we have 2 hydrogen atoms and 1 oxygen atom in this water molecule. Okay? Last but not least, if you guys ever see a giant number in front of that, that's what we call the coefficient. Okay? I'm sure you guys have heard the word coefficient a lot in math. In science, it's going to tell us how many molecules we have. So a big number in front says we have 3 water molecules. So it would be kind of like writing H2O 3 times. H2O, H2O, H2O. Okay? We have 3 water molecules. So if I were to ask you guys in those 3 water molecules, how many total hydrogen atoms do you have? What would you guys say? 6, right? 3 times 2 is 6. How many oxygen? 3. 3 times 1. So you have 3 oxygen atoms. Okay? We will use coefficients, not so much in the rest of this unit, but when we do reactions after Christmas, we'll start chemical reactions. You guys will be using coefficients to balance chemical reactions. Did you guys do that in 8th grade? Fair point. You guys got that on video now. Oh, so we will use coefficients a lot. The coefficients always go in front of the molecule. Never try to shove a coefficient in the middle, because then you guys have dranked up that whole molecule. Okay? All right, so what we're going to be spending the rest of today looking at is on page 20, we're going to do some examples where I give you guys some formulas, and you guys would need to write and tell me what elements are in that molecule and how many atoms of each element are in there. So let's go to page 20. We'll just kind of go through these examples together. Okay, Okay, the first one we're going to do, there's 7 total, so save room for 7. I did 2 columns in mine. However you guys want to do it is fine. Right, carbon dioxide is your first one, CO2. Okay, this is probably like the simplest you guys will have. As far as it goes, this is pretty easy. Okay, so Maddie, what are the 2 elements in this formula? And? Carbon and oxygen. Good. Okay, Garrett, how many carbon atoms do you have? 1. How many oxygen? 2. Good. And again, the subscripts just tell us that. Okay, we wrote the symbol for carbon, so we know there's 1. We have the symbol for oxygen with a 2 after it, so that means there's 2 of them. Pretty simple, right? Okay, when have I ever left anything simple for you guys? Never. So we're going to get a little bit more complicated. Obviously, we can look at something that has a little bit more elements in it. So let's see here. Grace, what are our elements in this compound? Sodium. Nope. Number 15. Phosphorus, good. And last but not least, oxygen. Okay. Libby, how many sodiums do we have? 3 sodium atoms. How many phosphorus, Libby? How many oxygens? 4. Okay. Getting a little bit harder because now what have we added, Merritt? Huh? Right, what is that called? That number in front? Huh? It is a coefficient. So now we've added a coefficient of 2 in front, meaning we have 2 molecules. So it would be like we were writing it twice. So we've got C6H12O6, which is glucose. So it would be like writing it twice. So when we are looking at the number of atoms, what are you guys going to have to do with this? Double it, multiply it by 2. Okay? So we've got carbon, we've got hydrogen, and we've got oxygen. Rachel, how many carbons do we have? We have 12. So 6 times 2. How many hydrogens, Ivan? 24. Good. And how many oxygens, Vicente? 12. Good. Okay, pretty easy, right? Not too bad. Let's make it a little bit more complicated. Okay, this is what we call a structural formula. We could easily add these together and write a normal formula where we've added up all the carbons and put them together. The reason for doing this is when you guys are in a couple upper level science classes, and you guys will see it in here, but you won't necessarily need to write the structure. But sometimes in chemistry, you guys write the formulas like this to kind of show what the atom would look like. So I would be like, all right, it's written like this, so I know the atom's going to look something like this. So by writing it like this, it tells me it looks like this. Okay? Does that mean you guys need to know how it looks? No. This is my first time writing that or seeing this formula. What you guys do need to know is to be able to add up those different elements and tell me how many carbons, Buck? 2, right? We have them in 2 different spots. How many hydrogens, Tristan? 4. We got 3 here and 1 here, so 4. And how many oxygens, Mick? 2. Good. Okay, that one's still pretty simple. Because of the functional group. Again, higher level. This one is different, and you guys are going to learn all about these. So this is going to be very common for you guys to see something with parentheses. The parentheses encapsulate what we call a polyatomic ion. You guys are going to get real familiar with polyatomic ions. Okay? This is one of the only things I make you guys memorize in this class is we have a certain amount of polyatomic ions that you guys need to memorize the formula and the charge for. They're ions because they're a charge, but they're also a molecule. So it's a whole molecule that has a charge. We see them a lot, especially in this unit and throughout the end of the year. This is a polyatomic ion hydroxide. It's important that you guys see this formula and recognize the hydroxide in there. Okay?
Your numbers are wrong there, by the way. Like your 3, like the question things. You skipped a number.
I think you skipped a number, sweetheart. blaming me. Did you guys see where the finger got pointed first? Uncool, Lib. All right. When you guys see the parentheses, what that means is whatever is inside the parentheses, you guys have 2 of. Okay? So again, it would be like writing OH twice. Okay? So here you would have OH, OH. That's an H and an O. Okay? So we have 2 OHs. Again, if you guys have a subscript on the outside, whatever's inside that parentheses, you have double the amount of. Okay? So for this one, we have calcium, we have oxygen, and we have hydrogen. Katie, how many calciums do we have? We have 1 calcium. How many oxygens, Jocelyn? 2, good. Again, it would be like writing 2 of them. And how many hydrogens, Tyler? 2. Okay, pretty simple, right? You guys will be working with those a lot, okay? Especially when we are balancing reactions, but in this as well. Next one, we got ammonium oxide. We've got nitrogen, hydrogen, and oxygen. Okay, again, we see the parentheses and a subscript of 2, so whatever is inside the parentheses, we have twice as many of. NH, why? It is clearly a 4. You guys are kidding me, right?
It looks like you erased it.
It's a Y?
It's a Y.
What? No, it's a 4. Thank you, Buck. I appreciate it. Good Lord. All right, Destiny. How many nitrogens do we got? How do you know I was going to ask you nitrogens? You're awfully sure of yourself. Devaney, how many hydrogens? So I have 8. So again, if we wrote NH4 twice, we'd have 4 plus 4. Or you guys can just multiply your guys' 2 subscripts. Okay, so 2 times 4 is 8. How many oxygens, Maddie? 1. Pretty simple. Okay? Don't you start with me. I'm going to write you guys a check, and it's going to be for like $1 for you guys' graduation. It's going to be a $1 check, but you guys are going to it's going to be such bad handwriting that you guys are going to think it's $1 million. And you guys are going to do like cartwheels all the way to the bank to cash this $1 million check, and it's going to be $1, and who's going to be laughing? Miss Crofutt's going to be laughing. Also, I don't get graduation presents, so look forward to that. All right, carbon and oxygen.
Just double checking.
Al2, parentheses, CO3, parentheses 3. That's Al! Good Lord, it's aluminum. Leave me alone. So again, it'd be like writing CO3 3 times. Anything to say about those guys? All right. How many aluminums do we have, Garrett?
We have 2.
Good. Maddie, how many carbons do we have? 3. Good. Again, 1, 2, 3, or 3 times 1. Okay. How many oxygens do we have, Rachel? 9. Good. So again, 3, 6, 9, or 3 times 3 is 9. Okay? Pretty simple, right? Ty, will you please take off your hat? All right, let's take a look at our worksheet. Let me pull this up for you guys. Oh, that's beautiful. I do love my smartboard. All right, so this is the How to Count Atoms worksheet. Okay, this is going to be due tomorrow. Depending on the time, we had little tech issues, so you may or may not. You guys should have enough time to finish this. Let's just go through the first one together, though. Okay, so the symbol of an element represents one atom of that element. So we're just talking about the symbol and what it represents. So Ba represents what? Barium. So you guys would write barium in there. Okay? I knew that was going to happen. Number 2. A subscript is a number written at the lower right corner behind the symbol of the element when there is more than one atom of the element. Then a subscript is used to indicate the number of atoms. So, for instance, this is what we call a diatomic element. The formula is Cl2. Okay? So, what do we have there then? 2 chlorine atoms. So you guys would write 2 chlorine atoms. Okay? Easy enough? Number 3, a subscript outside of a bracket, or in this case a parentheses, multiplies all the elements inside the bracket. So we have Ca3, parentheses PO4, parentheses 2. So how many calciums do we have there, Grace?
3.
How many phosphates, Ivan? Or phosphorus, excuse me. We got 2, so 2 times the number after the P, so 2 times 1 is 2. And how many oxygens, Vicente? 8. Good. Okay. The second number 3. Okay. Not the first number 3, but the second number 3. A coefficient is a number written in front of a chemical symbol and indicates the number of atoms of that element or number of molecules. So our first example says it has a coefficient of 3 and then it has C. So what does that mean? 3 carbon atoms. So you guys are writing there 3 carbon atoms. Okay, so let's talk about that. What is the difference in writing 3C versus C3?
3C's for the whole.
Right, either way we have 3 carbon atoms, right? But what's the difference between writing them like this? One is, I mean, if we wrote it like this, it wouldn't mean the same thing. Why? Merritt? They're separate molecules. The second we put a subscript, it makes it a molecule. Okay? These are 3 separate atoms. This is a molecule. Okay, so if we add a subscript, it's all of a sudden a molecule. So like that first example, that second example, I guess, it had Cl2. That is a molecule. Even though it's all chlorine, there's more than one chlorine, and that's our definition. It's either multiple atoms or multiple elements to form a molecule. Okay? All right, next one, 2NaSO4, which is technically the incorrect way to write that. I didn't make this worksheet. I stole it online. Okay, that's why there's 2 number 3s. I don't make mistakes. We all know this. How many sodiums do we have? 2, right? That coefficient tells us we have 2 NAs. How many sulfurs? 2. How many oxygens? 8 oxygens. Good. Last but not least, a subscript is a number written after an atom in a formula and indicates the number of atoms of that kind in the molecule. So H2SO4, which is sulfuric acid. The subscript of H equals 2, and the subscript of O is 4. What? Where are you seeing Na copper at?
Go down one more.
Does it?
It says Na copper.
I didn't make this again. I'm perfect. I would never make mistakes like that. Just like that. Put this down. Scroll down. Let's do that. Look at that. So just fix that. Na copper. Go ahead and fix that to sodium. No one else has noticed that today, so bravo. Including myself. Last but not least, let's do, on this example, we're going to do 4PbNO32. Okay? So on this page, the other side, the back side doesn't ask you this, but this page asks you how many molecules. So let's see here. Devaney, how many molecules of PbNO32 do we have? 4, right? How did you figure that out? Right. What is the 4 called? So that's the coefficient. Good. Okay. Lead. So then how many atoms of lead do we have, Maddie? 4. Good. Again, it would be like writing, oh, excuse me, wrong thing. It would be like writing PbNO32 4 times. Okay? And you guys can do that if you choose. That's up to you. Okay, nitrogen. Jocelyn, how many nitrogens are we going to have then? 8. Good. We have, in just one, if we look at just one molecule, okay, We have in one molecule of PbNO3, we have 2, but we have 4 of those molecules, so 2 times 4 is 8. So we have 8 there. Okay. Last but not least, oxygen. So this is going to be a solid number. Okay. Grace, what did you come up with for oxygen?
How many there are?
Yep.
24.
24. How did you do that?
Times all three numbers together.
Right. So she took 4, which is the coefficient, times 3 for the subscript of oxygen, times 2 for how many of the NO3s you have. Or if you guys look at it in one molecule, 3 times 2 is 6 oxygens in one molecule, but we have 4 oxygens, so 6 times 4 is 24. So you guys would have 24 oxygens. Okay? On the back side of this, you guys are basically doing the same thing, only it doesn't ask you guys how many total molecules you have. So you would write the full name. In this one, you would write potassium. This should be good practice for you guys to practice your names and symbols. So write potassium. Make sure you guys write the correct thing. And then the number of atoms, too. You guys will do that for the whole element. How many total atoms did you guys have in that? So you'd add up these numbers. Okay? Any questions? All right, cool. That is due tomorrow.